All right, we're going to do section 9.3. We're simplifying, multiplying, and dividing rational equations. This rational thing, what did we say that rational meant?
Fraction.
Fraction. And the fraction has x's in the denominator. Could be in the numerator also, but for sure in the denominator. All right. How to simplify rational equations. You can write this down if you wish. It's not required. It's up to you. You need to simplify. This means that the numerator and the denominator have no common factors. You have done this with fractions when you reduced fractions. With numbers, when we had fractions with numbers, you reduced them. That's what we're going to do, but we're going to use algebra with this, with x's and y's. All right, so the step you're going to do is you're going to factor the numerator and denominator. You've been factoring polynomials like with the box method. We did the factor by grouping. We did all these different ways of factoring in the past. All right, after you're done with that, you can cancel out what's in common in the numerator and the denominator. The trick is, I'm going to say this over and over and over, you can only cancel if you are multiplying. You cannot cancel if you're adding or subtracting. Only when you're multiplying.
I'm not going to lie. You had this hole right here from the projector, and I was like, oh my gosh, something really bad happened. And then I was like, I believe it's projected. Like,
That is the best. Got you. Carry on.
All right. We're going to talk about some excluded values. That's part of something that's going to be asked on your homework. This may be something you will want to write down. Excluded values, something that you cannot have for the value of x or the variable. This is the trick to this. What can never be in the denominator of a fraction? Ever, ever, ever. 0 can never be in the denominator of a fraction. You can never divide by 0. If you do, the whole math word falls apart, and then we'll just be terrible. So you cannot divide by 0.
That's what you want to
So that's what you'll need. For right here, what cannot be in the denominator of this fraction?
0.
0. Okay. For this one, what can x not be so that there would be a 0 in the denominator? A 3. So if x was 0 in this scenario, it would be impossible. If x was 3, it would be impossible. You with me so far?
Yeah.
All right. Let's do some. Number 1.
So you need us to write that down?
If you would like. I think you'll remember it.
Yeah.
But, okay. Number 1. We're going to factor. I am going to just simplify this one. You guys have done this one in the past. This is just...
2 into the 11.
What can I take out of a 12 and a 24?
12.
Okay, so 12 goes in there 2 times. I'd write it like that, correct?
2 into the... 2
And then what about
into
this
the
7, end of the 7 and end of the 4?
Cubed?
N cubed. So
Oh, yeah.
2n cubed is my answer. Are there any questions?
That was nice.
Okay.
I really hope.
What number was that? That's
Number 1.
Okay, we're getting there. We getting there. Okay.
All right, now we have to do the excluded value. We look at the denominator. What can n not be? What would make the denominator be 0? What could I put in for n that would make it be 0?
0.
0. So n cannot equal 0. If n was 0, then we'd have 0 times 12 or 0 to the 4th times 12. It all becomes 0. So that is my excluded value. N cannot be 0.
Is that required for the answer?
That's required for the answer. These 2 are required for the answer. Okay? I think what they're going to write on there, and when you see it on your answer sheet, for those of you, they're going to do a bracket and a 0. I think
multiple answers for.
there might be multiple excluded values. Yes. All right, let's do number 3. Number 3. Can I cancel out the k's right there?
No.
Why?
Because we're subtracting.
Because you're subtracting. The only time you can cancel out is if you're doing what? Multiplying. Okay. So I cannot reduce the 12 and the 20 either because we got the subtract in there.
You can do it by 2, though.
What can I take out of 12, k, and 8? Dividing.
3.
4. So if I take a 4 out there,
Shit.
what's left?
No, she's so sorry.
3k minus 2. All right. Now I am multiplying by that 4. You with me so far? Now I can reduce the 4 with the 20 on the bottom because the 20 and the k are being multiplied together and the 4 is being multiplied to that quantity right there. Now I can reduce. You have to factor first. So 4 goes into 20 how many times? 5 times. So I'll have 3k minus 2 over 5k. When you're going to do your excluded values, you need to look at the beginning or the factored version of the beginning, but not after it's canceled, okay? What could I plug in for k that would cause the whole denominator to become 0? 0. So that would mean that k cannot equal 0. Let's do number 5. Number 5, can I cancel out my a squareds?
No.
Because
Because we're adding.
we're adding. You have to be able to be multiplying. So what do we want to do with that numerator?
We can't do anything.
We can
Numerator.
do the box method. Thank you,
that's
Heidi.
right, we
Oh
can.
yeah, because I definitely.
A and A, what multiplies to be 60 that adds or subtracts to be 4?
Pardon me, 6 and no. One more time.
12?
What'd you say?
5
Um,
and 12? Yeah.
5 and 12, does that make 4 when you subtract?
No.
Makes 7.
6 and 2.
6 and 10, that makes 4 when you subtract, correct?
Yes.
Oh, we're
Okay.
doing the top.
We're doing the top. That's correct. I'm doing the top.
Oh, boy.
My bad. I'm sorry. All right, so
That's what I was saying.
6 and 10, which of those has to be negative so we can get a positive 4?
Negative 6.
Okay, so here we go. I'm going to have A minus 6 and A plus 10. That is now being multiplied, so I may be able to cancel something on the bottom with it. So let's do another box method.
6 and 2.
6 and 2, I heard.
And then we can just cancel out the
Negative
A's.
6. Negative 6 and negative 2.
Is that true?
Yes.
Both negative? Okay. A minus 6 and A minus 2. Let's just stop for a moment before you want to go
You cancel-
cancel
We can
happy.
cancel out the
We can
A's.
count A minus what?
6. You can
The whole group has to go in. A whole group of
Yeah, we
parentheses
can
has to be
cancel
canceled.
out all the, yeah.
You cannot cancel all the A's, just the A minus 6 and the A minus 6.
Okay.
Because this A plus 10 is adding now. But this A minus 6 is multiplying to this, and the A minus 6 is multiplying to this, so we can cancel all that. Before you cancel, let's do our excluded values. Let me explain why we're going to do it before we cancel, okay? It's A equals, all right? Cannot equal, right?
Positive 6.
We either have to look at our denominator or the factoring of our denominator. So A minus 6, what would we plug in for A so that this piece would become 0?
6. Positive 6.
Positive 6. What about this one?
Positive 2.
2. So A cannot equal 6
2.
or 2.
Or negative 10.
Both of them. No, the numerator, it's okay for the numerator to be 0. It's the denominator that can't be 0.
So we just circle that A cannot equal 6 or 2?
Yes, but our answer, when these things cancel, is A plus 10 up over A minus 2.
And that's the answer.
That is the other answer.
Just circle it.
Yes.
Sweet. Okay. So
All right.
let me jot that bad boy down. You said only the denominator.
That's correct. Only the denominator cannot be 0. The numerator is fine to be 0. All right, now we're going to multiply rational expressions. That just means we're going to multiply fractions. All right, so when you were multiplying fractions in the past, there was a couple ways you could do it. I have a fraction like back in the day when you were like,
Whoa.
you thought those were scary, but they're not too bad.
Still
You just
like
multiply across, correct? We just make that 18 over, I think, 48.
348.
Now, but there was a way that you guys learned how to reduce your fractions first, correct? We can reduce our fractions first instead of after, right? We can say 2 goes into 16 how many times?
8.
So we make that a 1 and that an 8, right?
Yeah.
And then we can do 3 goes into 9 3 times, right? These were each ones. So we have 3 8s. So we can reduce before, all right? We're going to do the reduction part by factoring, canceling out the common factors. All right. So the same instructions apply. We're going to factor the numerator and denominator. We're going to cancel out the common factors, but you can only factor if you're multiplying, not if you're adding and subtracting. All right. You just multiply across the top. That's the only difference. We just added a step. We were simplifying. Now we're just going to have a little more. We're going to add across the top and bottom when we're done. All right, here's number 9 and number 11. Number 9 is like what we just did. Can we factor any of those? Does 13, does 2 or 7 or anything go into anything?
No.
No, so we're just going to go across. What's 13 times 3?
I think that's 39.
I agree it is. What about 17 times 2?
38.
4.
No? Yeah, what, 34.
34.
What about our p's?
P to the 5th.
Yes. All right, now, when we also have excluded values on this. So our excluded values, we're going to have to look at all the denominators. There are two denominators here. The first one, 17p. What can this p not be so that everything would turn into a 0 on the jump? What about the second one?
0.
So we only have to write it once. So p cannot equal 0. You don't have to put 0, comma 0, just 0. All right, number 11. There's a couple ways to do this. You need to decide what's best for you. I don't know what I like. I do it different all the time. You could up here, you could factor it above it, or you could factor it below it, or you could factor it to the side of it. You need to decide what you want. So,
We don't have much room.
I'm going to just do it below it. I'm going to put a line and so there's 21v to the third plus 15v squared.
We can take a v squared out and a 3.
Take a 3v squared out. So 3v squared. What's left? So those of you who want to do it right above it, you could just put a 3v squared and put it there. And then eventually just put a little line because that was there. It's up to you.
Would be 7v and 5.
7v and plus 5. Okay. What about, now you have a choice now. You can go across to the v squared minus 25 or the 8v plus 40.
Anyways, so
Hmm?
you can't take anything. Oh wait, yes you can. It's a difference of squares.
It's a difference of squares, so it becomes what?
v
v plus 5 and minus 5?
Very good. Okay.
She was thinking it, it's just her mouth was like,
I
I don't really
refuse to be
feel
a
like
math major
it.
when I'm older.
Okay, you don't have to.
I cannot.
No
It's
stress.
like, oh.
What about 8v plus 40? What goes into that?
8.
All right, so v plus
5.
5.
It's the same as the top. Oh wait, we could have canceled those.
We
first.
could have been done. So I could have just
Same as
left
the
it because
top.
this right here is the same as that one, and we can just go away, right?
21v cubed plus 15v squared.
Oh.
Yeah, so we could have just canceled the whole thing with the whole thing because it's all
We
right.
extra. So should we, or what are we doing?
So I don't care. I already wrote it, so I'll just come over here, write v squared
Then
and
how are we gonna figure out our excluded values?
yes, very good question. How are we going to figure out our excluded values? All right, so let's do that first before we start canceling. Okay, so we look at this denominator.
I don't see how I'm simplifying it, to be honest.
I'll show you in a minute. You'll be simplifying it pretty soon. All right. So, what can I plug into this v so that this whole denominator becomes 0? What about just this?
3.
Negative 5.
Negative 5, because negative 5 plus 5 will be 0, and 0 times 8 becomes 0, correct? Okay, so v cannot be
Negative 5?
negative 5. That's the first one, because we have this denominator here and this one over here.
Okay.
So what can we plug into this one? Let's just do the 3v squared part. 0,
0.
right? Because this will become 0, and 0 times that stuff becomes 0, correct? So there's another one, 0. What about this 7v plus 5, though?
Explain how you get the 0 up there. I was still writing the negative 5.
Okay, so if I plug a 0 here, that'll be 0 squared, which is 0, times 3, which is 0, and 0 times that stuff will become 0. Okay.
Okay.
What about this 7v plus 5? What can I plug into there to make it become 0?
A negative something.
Negative something. So if you don't know, come over here on the side of your paper and write 7v plus 5 equals 0, and let's solve to figure it out.
So negative 5.
Minus 5.
5 over 7.
7v equals negative 5, and divide by,
Yeah, negative 5 over 7.
so it'll be negative 5 over 7. All right, now we're going to simplify it because that's what you wanted to do. You
Yes.
said this is not simplifying. So let's
That
get
is
let's
not
get a different color. All right, this v squared 7v plus 5 all cancels with that, correct?
Yep.
What else cancels?
The v
The two
plus
v's.
5.
But they don't, or because they're both on the top, does that work?
Well, no, the v plus 5.
Yes. Oh, when I say it has to be multiplied, it's something in a parentheses. So it's a v plus 5. So this v plus 5 and that v plus 5. What am I left with?
V minus 5 over 8.
Yes. So I'm left with v minus 5 over 8. Definitely that is way simplified than it was before, Isaac. Both of those are the answers. Okay.
Yes, I will admit.
That is simplified. Yes. We had to write a lot more stuff to get it there, but yes.
Yeah, but that first part
was not simplified. I agree with you. Here we go. Here we go. Now we're going to learn how to divide rational expressions. How do you divide fractions? Do you remember back in the day when you had to learn how to divide?
Second one and multiply.
Flip the second one. So we multiply. What do we say when we flip it? What do we call that? A reciprocal. So we multiply by the reciprocal. And it's always the second one that we flip, right? So this is going to become 2/3 times 27 over 6. Can I reduce this before I go?
Yeah.
2 goes into...
3 times.
2 goes into the 6 3 times.
9
And
over
3
3.
goes into...
So 3. Equals 3.
27.
How many
9
times?
times.
9 times. Oh, can I still reduce?
3.
Yeah.
I'm just saying
Yeah.
you-
So 3 goes into there 3 times. The answer is going to be 3. All right.
Big brained.
Big brain. All right. So when we're multiplying when we're dividing fractions, we're going to follow all the rules of multiplication, but one step first, we're going to flip this. All right. So we're going to factor the numerator and the denominator like we did before. We're going to cancel out our common factors. Make sure you're multiplying. Same instructions we had previous, right? So on number 15, what am I going to flip?
The 5 and the 4p.
Yes. So the 10 and the 10p stay. Now we're going to multiply by 5 over 4p. Now, our excluded values, there are more excluded values. Before we start canceling out, let's do some excluded values. Your excluded values are now the original denominators and the flipped denominators, okay?
50
So,
over 40p.
right over here on this beginning part, what cannot be in the denominator so that those denominators become 0? 0. Okay. So p cannot equal 0, correct? What about the new flipped one?
0.
Both of them can still not be 0, so there's only one, okay? Can I reduce anything up there?
Yes, all of the numbers.
The 5 and the 10, right?
Well,
I
why
can
don't you
take
just multiply
2.
straight through since they both have the same, and you get 50 over 40p, and then you get 5 over 4p.
You could do that. You could do
So
that.
Can I just write
Yes,
5 over
you can,
4p?
then reduce it afterwards. You could. And then 4, both of those can be reduced by 2, so I'll have a 5 and a 2, correct? So I'm going to get what over what?
I don't want to
5 over 2p.
I'll get more than 2p,
4p.
and more than just p.
Squared.
Yes. Okay? We need to flip this one. Do you guys want to flip? Do you want to factor first or flip first? It will not matter.
I say flip first.
Flip first. Okay. So we're going to go 8k minus 48 over k minus 6. That was the keep. We're going to change and flip. We're going to have the k squared minus 10k plus 25 over the 8k minus 40. Can I reduce? Can I cancel out these 8k's?
No.
Because I'm not multiplying. That's correct. Now we're going to be factoring. Now, be careful. Originally, this k squared minus 10k plus 25 was on the bottom. So it will be included in our excluded values once we factor it. Okay? Don't forget that. All right, what can I take out of 8k minus 48?
8.
So I'll have 8 and k minus 6.
I expected you to say 3.
And I have a k minus 6 on the bottom.
Last time was 3. She just went 3.
And what can I do with the k squared minus 10k plus 25?
It's funny.
Box method.
5.
I got k and k, and I've got 5 and 5? Negative 5 and negative 5, okay.
So just k.
You could write it squared, or you can write it k minus 5. I think I like k minus 5 both times.
I don't have enough room, so I'm doing the k minus.
Okay, that works. What about your 8 minus 40?
8. 1k minus 5.
Okay. All right, let's do our excluded values before we go further. Because when I start canceling, I can't see what I have.
So cos of 5.
So k cannot equal. All right, so I'm going to start over here.
6.
6, right? But over here, we have to do the numerator and denominator. Good thing it's only the same thing over.
Same
Cannot equal
It
5.
cannot equal 5 because 5 on the top and the bottom is, okay, so cannot equal 5. All right. Now let's start getting cancel happy here.
Woo!
All right. what about the 8 and k minus 6? What can be reduced? The 8s. Okay. And the
Negative k minus 6.
k minus 6s. I agree.
And the k
What about over here with the k minus 5?
Just two of them.
Just 2 of them, so we're just going to have k minus
We're going to have k minus 5 as my answer at the end. That is definitely more simplified.
Just so beautiful.
Isn't it all of a sudden it just bling, to
It's kind
nothing.
of funny though, because it's like k does not equal 5, like k minus 5. I don't
Now
know.
that whole thing at the beginning of number 17 was the same as k minus 5.
Oh, there's a 6. Ruined it. That's why it looked too pretty.
All right, this is what we did. We worked with rational expressions. We learned how to simplify. This was the beginning of all that. We had to make sure that we factored and canceled. And we had to when we multiplied, we factored, canceled, and combined. But when we divided, we flipped, factored, canceled, and combined. And every single one of them, we made sure that we canceled. We can only cancel if we're multiplying. I hope this has been helpful. Goodbye.